Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, determine the critical points for each function. Determine where the critical point is a local maximum or minimum and whether or not the tangent is parallel to the horizontal axis. So let's start with the first part, critical points. Now, critical points are points where the derivative of a function is either equal to 0 or is undefined. So we have to find the x values in this case that will make the derivative of this function equal to 0 or undefined. So the first step is to find the derivative of this function. So for that, we'll have to use chain rule. So prime of f at x. So this function is made up of the inner function x squared minus 1, and then there's this outer exponential function with the exponent 1 over 3. So we'll start with the derivative of the outer function, and for that we'll have to use the power rule. So we'll move the exponent to the front. So 1 over 3 parentheses x squared minus 1, and now we'll subtract 1 from the exponent times the derivative of the inner function, and the inner function is x squared minus 1. So for x squared we'll use the power rule, and the derivative of x squared will be 2x exponent 2 minus 1. So we move the exponent to the front and then we subtract 1 from the exponent. Now the derivative of 1 is equal to 0 because 1 is a constant. Now we can simplify this expression. Simplify the exponent. So 1 over 3 minus 1 is equal to negative 2 over 3 because the denominator of 1 is 1, and if the common denominator will be 3, so we'll get negative 2 over 3. And at the end, so then minus 0 will go away, so we'll be left with just 2x. So the exponent is 1, but we don't write 1 as an exponent. Now we can multiply 1 over 3 by 2x, so we get prime at x. So we get 2x over 3, and we can move x squared minus 1 to the denominator to make its exponent positive. So it will become x squared minus 1 exponent 2 over 3. So this is the expression for prime of f at x. Now we'll have to find the x values at which the derivative is equal to 0. So we'll sub in the left side as 0. So we get 0 equals 2x over 3 parentheses x squared minus 1 exponent 2 over 3. Now we can cross multiply the denominator because we have to solve for x. So 0 times any term will be equal to 0. So we get 0 equals 2x. And now we can divide both sides by 2 to isolate x. So the 2's with the x will go away. So we are left with just x equals 0. So this is our first critical number. Now we should find the x values that will make prime of f at x undefined. Now prime of f at x will become undefined when the denominator of this expression becomes equal to 0. So for that, we should sub in the expression in the parentheses equal to 0 and find the x values that will make the denominator equal to 0. So we have to solve for x. So first we'll add both sides. So on the left side will get cancelled out. So we get x squared equals 1. And now we can apply square root to both sides to change x squared to x. So on the left side, the square root and the square will cancel each other out. So we'll get x equals plus minus 1. So that means there are two more critical numbers, x equals -1 and x equals 1. So this function f at x has three critical numbers. Now to find the critical points, we should sub in these x values one by one in the given function to find the function value. So let's start with x equals -1. So f at -1 equals, so -1 squared minus 1 exponent 1 over 3. So f at -1, so -1 square is equal to 1. So we get 1 minus 1 exponent 1 over 3, and 1 minus 1 is equal to 0, and 0 exponent 1 over 3 will be equal to 0. So the first critical point is -1, 0. Now we can find the second critical point. So we can sub in x as 0. So f at 0 will be equal to 0 square minus 1 exponent 1 over 3. So f at 0 equals, so 0 square is 0 and 0 minus 1 is -1 exponent 1 over 3. So this expression is equivalent to cube root of -1. And cube root of -1 is equal to -1. That means the second critical point is 0, -1. Now we can find the third critical point, so we'll sub in x as 1. So f at 1 equals, so 1 square minus 1 exponent 1 over 3. So 1 square is equal to 1 and 1 minus 1 is equal to 0. So f at 1 is equal to 0 exponent 1 over 3, which is equal to 0. So the third critical point is 1 comma 0. So these are the three critical points for this function. Now we have to analyze the second part. So it says determine whether the critical point is a local maximum or minimum. Now for that we can use the first derivative test. So we can use the number line method to find whether the function is increasing or decreasing on both sides of these critical points. So we'll start by drawing a number line and showing our critical numbers on it. So the critical numbers we got are -1 and then 0 and then 1. So these critical numbers divide the number line into 4 parts. So we'll have to use a test value from each part. So for the left part we can use the test value -2. Between -1 and 0 we can use the test value -0.5. Between 0 and 1 we can use the test value 0.5. And to the right side of 1 we can use the test value 2. Now we have to sub in these test values in the prime of f at x, because as you may remember, the function is increasing if the prime of f at x is greater than 0, and the function is decreasing when the prime of f at x is less than 0. So the expression for prime of f at x is this one. So let's start with -2. So we can sub in x as -2. So prime of f at -2 equals 2 times -2 over 3 parentheses -2 square minus 1 exponent 2 over 3. So 2 times -2 is -4, and in the denominator, so 3 parentheses, so -2 square is +4, and 4 minus 1 is 3, and then exponent 2 over 3. So in the numerator we have a negative value, and in the denominator we'll get a positive value. So the overall result will be a negative value for prime of f at -2. That means the function is decreasing on the left side of critical number x equals -1, because prime of f at -2 is a negative value. Now we can do the check for the second test value. So prime of f at -0.5. So we get 2 times -0.5 over 3 parentheses -0.5 square minus 1 exponent 2 over 3. Now in the numerator we get -1, and in the denominator, so we have 3 outside the parentheses, and -0.5 square will be positive 0.25 minus 1, and then exponent 2 over 3. So we can simplify it. So we get -1 over 3 parentheses -0.75 exponent 2 over 3. Now the denominator will be a positive value, because if we simplify it, so I can show it to on this side. So we can break down the exponent 2 over 3 as, so 3 times, and then cube root of -0.75 square. So the square will make the -0.75 a positive term, and then we'll do the cube root of the positive term. That will give us a positive result. So in this case, so the numerator will be a negative and the denominator will be a positive term. So the overall result will be a negative. So that means the function is decreasing between the critical numbers -1 and 0. Now we have to analyze the prime of f between 0 and 1. So we'll sub in the test value x as positive 0.5. So prime of f at 0.5 equals, so 2 times positive 0.5 over 3 parentheses 0.5 square minus 1 exponent 2 over 3. So in the numerator we just get 1, and in the denominator, so we get 0.5 square is 0.25, so 0.25 minus 1 exponent 2 over 3. So we are getting the same expression that we get in the denominator that we got for x equals -0.5. So 1 over 3 exponent -0.5 exponent 2 over 3, which can be simplified to, so 1 over 3, and then the cube root of -0 point square. So we'll get a positive result in the denominator. There's positive value in the numerator. So that means prime of f at 0.5 will be a positive value. So that means the function is increasing between the critical numbers x equals 0 and x equals 1. Now we can analyze the behavior of the graph to the right side of critical number x equals 1. So we can sub in x as 2 in the prime of f. So we can do the calculation here. So prime of f at 2 will be equal to, so 2 times 2 over 3 parentheses 2 square minus 1 exponent 2 over 3. Now we can simplify this too. So 2 times 2 is 4. In the denominator we get 3 parentheses. Now 2 square is equal to 4 and 4 minus 1 is 3. So 3 exponent 2 over 3. So in this case we are getting a positive result in the numerator and a positive result in the denominator. So the overall result will be a positive value. So that means the function is increasing on the right side of critical number x equals 1. So now we can use these results to find where the critical point is a local maximum or minimum. Now as you may know, so a critical point is a local maximum when the function changes from increasing to decreasing, and the critical point is a local minimum when the function changes from decreasing to increasing at that critical point. Now in this case, the sign of prime of f is only changing at the critical number x equals 0. So that means the critical point 0, -1 is a local minimum, because at x equals 0, the prime of f at x changes its sign from negative to positive as we go from left to right. So that's our first conclusion. So we can write here. So critical point 0, -1 is a local minimum because prime of f changes from negative to positive as we go from left to right. So this is a very important concept we need to understand and memorize. Now at the other two critical numbers, the sign of prime of f is not changing. So that's why the other two critical points do not represent a local maximum or local minimum. So we can write a concluding statement for that. So the other two critical points, so -1, 0 and 1, 0 are not local maximum or local minimum. And the reason is because the sign of prime of f does not change on the sides of those critical numbers. So we have answered the second part of the problem. Now the last part is whether or not the tangent is parallel to the horizontal axis. See, the tangent is parallel to the horizontal axis at x value where prime of f will be equal to 0. Now in our analysis, so when we set prime of f equal to 0, we got the critical number x equals 0. So at x equals 0, so prime of f is equal to 0. So therefore, the tangent is parallel to the horizontal axis at the critical number 0, -1, or critical point, sorry. So we can write, so tangent is horizontal at critical point 0, negative. Now the other two critical points are points at which the prime of f is undefined. So that means we can conclude that at critical points -1, 0 and 1, 0, so at tangent is not horizontal. So this is a very important concept you need to understand and memorize about identifying whether the tangent is horizontal or not. So I just draw this line to show that these are two separate results we write. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.